So thank you, everyone, for joining us for this latest installment of the SimCenter's Community Roundtable meetings. The goal of these meetings are to give our community of users and partners an opportunity to engage with the SimCenter and its various experts and colleagues in talking about issues related to our various working groups. And today, we will specifically be diving into the work around hurricane regional simulation. Our goal with this particular session is to offer some opportunity for you to see the new directions that these workflows are evolving toward and have an opportunity to share some of your preferences and desires for where they go next. And so today's roundtable will be facilitated by myself. My name is Tracy Kijewski-Correa. I'm at the University of Notre Dame. And so with that, I'll do a little bit of housekeeping. So again, today's engagement is meant to help showcase these new capabilities that are coming online, previewing some of the latest things that are to come. We'd also like to use this then as a chance for quick feedback loops. We'd like to hear from you about the capabilities you'd like to see in these areas, what could bring the greatest value. And to help in those conversations, we'll have a few questions that we'll present at the end of each segment to get your wheels turning. And that's with the hope of course, fostering some dialogue within our community of researchers around this, with the hopes that we all contribute, collaborate, and build off of these capabilities. So the agenda for today will begin with first a presentation on our overall approach to regional simulation. We'll have some discussion and then followed by our second presentation on expanded damage and loss models. And then we will move into our inventory generation capabilities and finally close with some instructions on how you can stay involved and other upcoming roundtables. Just with respect to housekeeping, we are in a webinar style format. So the idea here is we will have the ability to use a Q&A function to pose questions, or you could even enter things into the chat. And this will allow us to kind of engage with your questions either in a direct response or verbally during the discussion point. So feel free to get those questions in as we go along the way. And you can even raise your hand during the discussion segments and join in a live conversation. We want to create opportunities to provide feedback to us either in writing or verbally, whichever you prefer. During our question and A period, again, I will try to engage the questions and discussion points that I see, but again, you can raise your hand and live participate in each of the discussion periods after each of our 3 formal presentations. I do ask that you take a moment to mute yourself and to only come off mute when it's your time to engage so that we eliminate background noise for the other attendees. And now I'd like to invite, as the first exercise in using our mute buttons, our 3 presenters to come off mute. And if they'd like to just briefly introduce themselves to you, this will allow you to meet each of our presenters. Adam, would you like to begin?
Yes, hi everyone. My name is Zsarnóczay. I'm a senior research engineer at Stanford University and one of the associate directors for the SimCenter.
Rachel?
My name is Rachel Hamburger. I'm a PhD student at University of Notre Dame, PhD student of Tracy, actually. But I've also been a SimCenter graduate student intern for the past 2 years.
Barbaros.
Hello, everyone. I'm Barbaros. I'm one of the software developers at Near SimCenter, and I primarily work on inventory creation tools that I'll be talking about later today.
Excellent. And these images suggest the sequencing of our talks today. So actually with that, I'm going to stop sharing my screen and invite Adam to take over the controls to take us first through the initial presentation that we'll have today, which will give you an orientation to our regional simulation capabilities. Adam, it's all yours.
Thank you, Tracy. Can someone confirm that everything looks good?
Yes, we can see you and hear you.
Thank you. Perfect. So I will spend the next 10-15 minutes to give everyone an overview of our current capabilities and what we are looking forward to in the next 6 months when it comes to regional hurricane risk simulation within the SimCenter platform. I would like to start by taking a step back and explain to you how we think about the framework for risk assessment conceptually at the SimCenter. We started with looking at the original peer performance-based earthquake engineering framework and expanded it with a couple key ways to make it available and enable regional risk simulation. First, we introduced regional scale hazard modeling instead of looking at a single asset, and we implemented a method to look at each asset in a large number of assets with different simulation workflows so that we can tailor the workflow to the particular type of asset that we are analyzing. And then added recovery analysis to the end of these workflows so that we can look at the longer term impacts of these disasters. Finally, the last piece of the puzzle was inventory modeling and household models so that we can feed some critical data into these simulations and into these simulation workflows at the regional scale. Now, once we have this conceptual framework, we had to implement it in a software platform so that you all are able to run those simulations for your studies. Our platform at the very high level consists of a backend which does the calculations and a couple of different front-end desktop applications that help users set up those simulations and then post-process and visualize the results. Now, beyond just focusing on how to run the simulations, we understand that there are a couple of other critical steps a researcher has to take to collect the data, set up those simulations, and then process the results. And we want to make sure that we provide streamlined approaches for those who want something that is readily usable and still provide the kind of flexibility for those users who want to bring in something new, who want to extend these simulations with their own models or with the new methodology that they are working on. We have a number of different use cases identified, and we fill this matrix with different ways we can contribute to those. And you can choose your own adventure from the left to the right, going as deep into flexible custom methods as you need. I won't describe all of these in detail. I just wanted to emphasize that one of the key things that we do is try to make sure that we cater to these automated, streamlined approaches as much as to the flexible, user-driven ones. Now, when it comes to hurricane risk simulation, one of our key visions is bringing closer the local scale, high fidelity analysis and the regional scale risk assessment in a hurricane context. This starts with looking at what we do at the local scale. At the local scale, we have two key applications that support these high fidelity simulations, and I'm going to give you a quick overview of them now. The VUQ tool, which is our wind engineering with uncertainty quantification application, provides you access to state-of-the-art computational fluid dynamics analysis, as well as stochastic methods and a way to import experimental data to describe a wind field, and then access to structural response simulation using finite element modeling and state-of-the-art uncertainty quantification tools so that you can do this in a probabilistic setting. And if you are interested, you can also train surrogate models for those analyses within this tool. If you take a step further from looking at structural response, the next step is damage and loss. We have our own damage and loss modeling engine called PELICUN, coupled with a damage and loss modeling library that includes fragility and loss functions. Rachel Hamburger will talk about that later today. And this tool is accessed through the PBE application. PBE is the desktop application with a user interface that makes it easier to set those simulations up. You can import demands such as pressures on a building envelope from VUQ into PBE and then run those damage and loss simulations. And we are looking forward to expanding into recovery. Right now, PBE supports recovery simulations for single buildings in an earthquake context, but the framework is there to do the same for hurricanes. Once we have these local simulations set up and we are able to run them, the next question is, how do we use what we learned there in a regional setting? So if you have a building portfolio and you are looking at individual buildings, you could theoretically run a high fidelity simulation for every single building. But rather than doing that, what we are exploring is this multi-fidelity approach where you identify different classes or groups of buildings in a regional simulation, and you apply the right level of fidelity and the right approach in terms of modeling to each class. You can bring models from libraries of surrogate models or libraries of high fidelity archetypes, or you can bring your own model and use that in the analysis. Our platform is designed to be able to support all of these within a single analysis, so you don't have to run separate simulations to be able to cover all of these different modeling approaches. And this is orchestrated in R2D, our regional simulation tool. So let me give you a quick overview of that tool next. R2D starts with identifying hazard events through intensity measure fields, and you can take those intensity measure fields, couple it with the building inventory information or lifeline information for the area, and calculate responses, damages, and then look at the recovery from those damages within a regional scale. R2D supports multiple types of hazards. It supports multiple types of assets, including utility networks, buildings, and transportation networks. And as I mentioned, it supports this multi-fidelity approach to simulating response and damage. So the last step here that's very important in our vision is to encourage the kind of feedback from regional to local that can guide the development of the next generation of local scale models and help those in the community who are focusing on those local analysis or experimental work to identify what are the key missing pieces or gaps that could be covered by their work to inform the regional studies. So this is the way we are trying to bring those two traditionally different areas together and have an interplay between local and regional studies through our platform and our tools. Now let's look at what are the possibilities within our simulation platform for each step of these regional workflows, going from inventory all the way to losses and recovery. I will cover what we are working on right now and what are the interesting new features that we are bringing in so that we can have a good discussion, I hope, after the presentation. One of the key things for every step is data schema. Standardizing the data that we use is an important way to help people share the data between each other and to help us share data with you and import that data into our applications. So we are developing a data schema for inventory data. It's based on a GeoJSON format, and we are also leveraging that schema in our Braille++ application. Barbaros will talk more about Braille++, so I'm not going to spend time on it now, but that's one of the highlights of our developments. So I'm not spending time on it because it's so important. We gave it its own presentation. When it comes to event modeling, we used to use a CSV-based schema. We are switching to GeoJSON. That's in development right now, and it will support bigger intensity measure fields and the combination of multiple different intensity measure fields. So that makes our platform more versatile and cater to these multi-hazard type of studies that we see on the horizon. One of the key ways to work with events is importing these results of expensive simulations. What you can see here is an AdCirc simulation result of storm surge for Fort Myers, but there could be a wind field coming from a similar simulation, or in an earthquake context, you can imagine something similar. But beyond just importing those fields, we want to support other types of studies. So we have a hurricane simulation tool that brings the opportunity to researchers to run their own hurricane simulation using their own hurricane track. And it's a probabilistic, but of course, simpler simulation than what you would imagine from a weather model. And it allows you to bring wind fields for a specific hurricane into your study if such wind fields are not available otherwise in the literature. The third option that you can see here is a physics-based analysis at the neighborhood scale, which would connect to larger scale analysis from a weather model or from a large scale wave simulation and allow you to bring the extra fidelity at a smaller but still regional scale and run a fluid analysis there so that you can capture the impact of buildings and vegetation on those flow fields. When we go on to response and damage simulation, there are two important libraries that we have. One is collecting CFD simulation results. So if you're doing a CFD simulation yourself on a single structure, we would welcome the results of that in the library. And we are also making it very easy for those who are running simulations with our VUQ tool to submit those to the library. When it comes to damage and loss, we have the library that Rachel Hamburger will talk about, where we collect fragility functions and loss functions and make them available to the members of the research community. when we talk about how to calculate response and damage in our platform, hazards, wind, and flood methods are already available. So you can use our platform to reproduce hazard style analysis. And Rachel will talk about how we want to bring this to the next level with the high resolution wind performance assessment approach that we have been working on. And finally, surrogate modeling we see as a very important new development in the last 10 years in our field. And we want to support those efforts so that we can bring high fidelity models without the very expensive calculations that they involve. Finally, losses and recovery. In this side, we have a data schema to help people pick up the results of our simulations, damage results, or even loss results, so they can post-process and build on top of them. But we also want to build in as much as possible of the efficient methods that are available to look at socioeconomic impacts. So we are looking at a Seymour Spence's group's approach to building recovery simulation that allows to give us a rough idea about how buildings would recover after a hurricane. We are working with Elena Sutley to bring in her household displacement model. And we are also exploring the impact on electric power networks and want to allow people to do studies of these interdependent effects using a simple electric power performance model. So all of these come together into this set of features that we plan for the next couple of months. And one way to demonstrate these is our test beds. We want to revise our test beds that we've been working on for, I believe, 7 years or so now. And we want to revisit them, regenerate inventories, and collect event information, and provide example workflows for the community that can serve as templates and that can serve as opportunities for benchmark studies. To give you an idea of how such a testbed would look like, I bring this slide about Fort Myers and our plans for that. We plan to share key data pieces that can help people start working in that area. This includes asset inventories, event intensity measure fields, simulation scripts and the outputs of those simulations, key reconnaissance data that can serve as ground truth, and a collection of the relevant reports about the events that happened in that site. And the organization of this could be that we have an umbrella project in DesignSafe linking to the available resources so that we don't try to own these data. We are just helping everybody to discover the data, but providing the credit. Okay, so giving credit, yes, through linking to their projects rather than owning the data ourselves. So there are 2 more bullets here. It's important that we could share the information about private resources that are available, but maybe not accessible to everyone. Information on an embargo that tells people that certain resources will be available in the future, that can help them anticipate such resources and plan for working with them. And it's also very important to have minimum metadata requirements so that people don't just dump data into this collection, but provide the necessary information for others to be able to use and leverage the information there. So this is our plan. We are going to work out these details and start collecting the data and sharing it with the community in the next 6 months. And we encourage everyone who is interested in these testbeds to reach out to us. We would be very happy to work with you. And this arrives, now I arrived at my questions. I don't know, Tracy, if I should read them right now or.
Yeah, well, let's go ahead and put these up. I mean, Adam, thank you for just helping the attendees to understand, first of all, the extensibility that's being built into this workflow to accommodate both many different styles or approaches to tackling the different, as we call them, puzzle pieces in this workflow, but the importance of being able to allow community members to contribute or bring their own analyses or their own data to the process, right? Those are 2 big takeaways. I remind all of our attendees, we're going to have about a 10-minute window here to have some discussion around Adam's presentation, which set a big table. It showed you the overall workflow and some of the new features that are coming now, and we'll dive into more today. And it also highlighted the test beds as this important venue to see some of these capabilities exercised in real-world application. Adam has presented 3 questions, and so I will pause here and offer 2 opportunities. The first is, if you have an immediate question independent of what Adam has on the screen, and you'd like to put it in the question and answer, I please encourage you to do so. But then I'd like to monitor that while opening the opportunity for some more conversation around these 3 questions that Adam presented. And maybe I will jump to the one that everyone sort of talks about, and it's quite obvious, is about the kinds of data you'd like to bring into a workflow like this. This is the 3rd question on the screen. Adam gave you some indication of the different types of data and analyses we're thinking of enabling, the different types of infrastructure or building inventories that we might examine, and even when we think about loss and recovery, some of the different features we might be looking at. For the kind of work you're doing, and feel free to use the chat or raise your hand, are there any data types that we're missing that would be essential to doing an end-to-end regional simulation to be able to demonstrate the impact of a hurricane on a community in the ways that matter most to your work? Is there anything we're missing here that you'd like to see? And Adam, as we kind of give the community time to reflect on that important question, are there wish list pieces of data that you've been thinking about? Obviously, we have finite resources and time. We've prioritized areas where our working groups have made progress. You highlighted Seymour and other colleagues who have work that we're trying to integrate. Are there things you wish you had that maybe the community online here today has that we could bring in if we found a worthy, kind of opportunity for collaboration?
I do have answers when it comes to the high resolution wind performance assessment, but I think those mostly belong to Rachel's part. I think there are a lot of opportunities there where I know that a lot of people are actually working on those things. Another area that would be very interesting, in my opinion, is collecting more information about non-building asset types and how they are impacted by hurricane. And we can look at the damage, but we can also look at how they are affecting the recovery. If anyone sees gaps, and I think there are gaps still in our current capabilities, I would love to talk to you and explore how we can plug those in.
And in terms of what at least you're seeing, I mean, as you said, non-building types, we've talked a lot about networked infrastructure, and that some of the infrastructure networks that might be most relevant to hurricanes would be different from earthquakes, right? So we'll need to diversify the inventories that we're representing from an infrastructure perspective. I know one area we've talked about in the center, obviously, are things like power, for example, power networks, quite vital. Again, offering the community an opportunity who's assembled online here, if there are networks that are critical to restoration, recovery, and continued functionality in regions, power is one that we've talked about. Are there others we're missing, right? That's one to think about. Transportation networks, which are critical for reentry and reoccupation post-event, I think is another we've discussed. But I think you're correct. Our ability to describe those assets is somewhat limited by what we have available to us today in the center. One other area, and then I have an open question here that is coming from Greg. He asks, can you comment on available resources for generating the intensity measures for wind and surge? What are we having here today, and are there areas where the community might even be able to help us do even better?
Yeah, so what we do have, I mentioned we have this hurricane simulation tool that uses a model that's similar to what Peter Vickery started, and the one we use is an upgrade to that or update to that by Teng Wu. He generously offered his help and collaboration, and we built in his version of the same model. So that allows you to generate a wind field from a hurricane, but it doesn't give you storm surge, for example. For storm surge, we are looking at these neighborhood scale simulations that would allow you to link or interface with an AdCirc model or AdCirc style model, but use something maybe like a Buzinesque style approach to capture finer details of the flow field and the buildings and vegetation's impact on it. We don't have that right now, but we are working on it. So that's not just a vision, that's something that is being actively developed and integrated into the platform.
And I think, Adam, what's interesting is the extensibility that we're talking about in the platform. As you brought up things like vegetation, these localized features, I think it's important to also remind the community that even though we aren't explicitly, adding those capabilities today, it doesn't mean they can't be incorporated when we have community members that could bring those capabilities. I think vegetation and roughness and ways to actually bring those site level effects or these kind of upstream features into the simulation is something that I think would be a great contribution in place where we could build. I've heard conversations about vegetation and nature-based solutions and creating libraries for those to be brought into the simulation as a suite of features that someone could bring in to look at their effects then on attuning the, the wave field, or, in the case of wind, changing the site-specific wind speeds that you would see from these larger scale simulations that are coming in almost as the input to a larger, more refined representation at the site level. I think one more thing, Adam, I'd like to just get your thoughts on, as I'm really trying to also push for additional methods and provoke the community to think about where they might be able to take advantage and contribute. Oh, we have a question in the chat, so let me pivot there real quick. It says, does the hurricane data on DesignSafe give the time series of a single hurricane, so that, the full path of that hurricane over time? And she said, I need correlation of data in a wide region of, let's say, 2 miles wide in the path of a hurricane when doing some system level analysis. So kind of trying to understand, have we tapped into the full amount of data in DesignSafe that would allow us to take a look at some of these things and do a full-time series investigation?
I am not aware of full time series being released on DesignSafe, but I might not be aware of everything, right? ARA, typically they are the ones releasing such data. They release an envelope wind field. So if you want such data, I think you would be more interested in these local scale or neighborhood scale analysis potentially, which can give you a time series. If you want to go bigger than that, I think it's going to get very expensive. But that's just my take. Maybe there are people in the audience who are more aware of the resources available.
Yeah, my understanding is things that are carried out in DesignSafe don't have that kind of data, but that they may be available elsewhere through other providers. It's just not something I believe has been contributed into DesignSafe, which is largely driven by the research community. So yeah, thank you for that, Foria. So Adam, any parting things that you'd like to leave? Because again, the goal of this is to put these thoughts in the mind of the community so they see where we're going and know that there's an open invitation to engage. And I'll be showing how to do that at the end of this roundtable, but also to reach out and share, again, ways that we could streamline tasks, additional workflow features or methodologies you'd like to see in these, and data. How would you like the community to let you know if they see opportunities in any of the 3 areas here to contribute back?
Well, in any way that's convenient for them, I'm happy to have, to hear about it, either today, like during this event, if they speak up, or if they send a message. They can send me a private message on Zoom if that's more comfortable. We will have ways to respond to our prompts. Tracy will talk about that later in this event. You can send me an email. We have a newsletter at SimCenter. You can hear more about us there. You can also send an email to our central SimCenter email. There's many ways to express your interest. One thing that I would like to stress is that we are not only interested in folks who can provide us more data or who can provide us new models. If you would like to use this platform, but you see some things that are missing, let us know, because we might be able to provide those missing pieces pretty easily, and then you can start leveraging this simulation platform. So I would like to hear about anyone who is interested in using what we have and see how we can make it useful for you.
So that's an excellent plug to not only contribute, but just to use and begin to engage, because that's the best way to understand the capabilities, use it to enhance your research, and then more importantly, help us see how we can serve the community better. So thank you, Adam, for that important reminder. If you wouldn't mind stopping share on that, we're going to bring Rachel in. Rachel was cued very nicely by Adam in signaling some of the ways we're trying to improve the damage and loss modeling capabilities in the SimCenter in the area of wind hazards. And so I'll let Rachel bring up her slides and introduce you to a new contribution that's not just coming soon, but actually is well on its way. And Rachel, I'll turn it over to you.
Great, yes, thank you, Tracy. So today I'm going to be talking about how we integrated high-resolution methods for hurricane risk assessment into the SimCenter, and how we used a unifying framework to organize these models. So through this study, I think Adam touched a little bit on this in his presentation, but we were interested in understanding this concept of high-resolution hurricane risk simulations. And historically, methods for regional risk analysis and performance-based design were developed independently, with the former relying on more simplified damage and loss models to assess large building inventories, and the latter focusing on these detailed assessments of individual structures. However, with the modern high-performance computing capabilities, these assessment methods are converging and will eventually permit high-resolution regional simulations. So it was our goal to bring these granular damage and loss models into the SimCenter's existing computational infrastructure. And prior to this work, the SimCenter already had employed building-level hurricane damage and loss analyses using FEMA's HAZIS data. But for the earthquake simulation, they already had component-level analyses using resources from FEMA P58. So we wanted to bring the computational capabilities up to the same level of resolution. And to begin this, we first wanted to understand the current state of the art in the field. So we reviewed over 70 papers and used these insights to build our unified framework to organize all the available methodologies. And the architecture of the framework is a matrix with rows outlining performance-based engineering steps, columns outlining the steps, and then rows outlining the resolution of the study, including building, subassembly, and component level methodologies. Now you'll notice in this figure that the framework is not specific to any one hazard, but with a thorough enough understanding of the literature, it could be populated for a specific hazard context. So that's exactly what we did with our literature review, which focused on 3 hurricane wind demands. And we used what we learned from those studies to populate each of the matrices. And the 3 wind demands that we were considering are wind-induced pressure, wind-borne debris, and wind-driven rain. And without taking too much time, I just wanted to introduce you to the populated matrices for these that we have created. In red, we have our wind-induced pressure workflow, which is really the foundation of our hurricane simulations. And then in purple, we have wind-borne debris. And finally, in blue is our wind-driven rain. And just to note that although wind-driven rain doesn't usually directly contribute to structural damages, the resulting content and interior losses are very substantial. So accordingly, most of the work in that area is going to be concentrated in that loss section. And then after we used our papers to populate these matrices, we then went back to the literature and revisited the studies and mapped each of the studies through their respective frameworks as a sort of validation exercise. And so these Sankey diagrams are visualizations of how each of the papers travels through our proposed framework. And you'll notice from the figures that there is a high concentration of studies that fall into that high resolution category. And this is because we did tend to focus our literature review on methodologies with a high resolution because we had the ultimate goal of implementing these methods into the SimCenter ecosystem. And I just want to note before I move on that if you're interested in the studies that we used for this literature review, I'm going to be providing a link to a database of all of the papers at the end of the presentation. So far, I talked mostly about how we used our how we organize the literature into a cohesive schema, but we also had the goal of making these simulations more accessible. So to do this, we provided some supplementary materials. And this screenshot on the screen here is an example from our calculation set / model parameter library. And it shows component unit fragilities that we compiled for the pressure analysis. And in the table, you'll see there's information about the asset and the specific failure mode that's investigated. We then have fragility parameters and the model type. And then finally, we have, of course, the original sources to ensure that there's proper credit attribution for reuse. Now, although our review was comprehensive of methodologies at all resolutions, for the rest of the presentation, I'm going to focus on just the component level resources that we compiled and implemented. So this is a table of the component level fragilities that we have. And as you probably would expect for a pressure analysis, we found fragilities for both primary structure and building envelope components. And then for our debris analyses, we found mostly building envelope fragilities. And then, as I mentioned earlier, typically for rain, the effects are quantified in terms of loss. So we found some loss models for the interior electrical, plumbing, and mechanical systems to quantify rain losses. Now, these compiled libraries have been added to the SimCenter's publicly available damage and loss database. And in this database, fragility parameter information is available in a CSV file that can be easily exported for independent use. And then there's also metadata for each model that's stored in a JSON file. And in this JSON file, the metadata includes just brief descriptions of the asset and also information about the originating study, again, which could be used for bibliography generation if you reuse the data. Now, that QR code on the right of the screen is going to take you to the SimCenter GitHub page, which is where this damage and loss library is housed. And if you miss it, I'll send out the links in the chat at the end of this presentation. But before I move on, I just want to emphasize that currently only the pressure component fragilities are currently in the damage and loss database at the moment. And so in addition to the raw data being added to the damage and loss database, SimCenter workflows, specifically the PELICUN tool and the PBE application, were updated to enable this component level damage simulation. So I'll briefly step through the process of performing one of these simulations using our new resources coupled with existing SimCenter tools. So first, the user can use the WeUQ application that Adam talked about to find component level pressures from a CFD simulation that will be hosted on DesignSafe. And then from there, a component level damage analysis can be conducted through the PBE application, which begins by querying that damage and loss database and assigning appropriate fragility parameters to the components. And then the application will perform a probabilistic simulation workflow, which ultimately will determine if the component limit state is exceeded. And I want to note that although this can all be done through the easily interpretable GUI of the PBE application, if the user is interested in integrating this tool specifically into their larger workflows, then the same simulations can be performed in a Python environment through the PELICUN tool rather than the PBE application. Now, I'll quickly unpack the theoretical workflow that helped and hopefully will continue to help to shape the tools that are implemented into PELICUN and PBE. And this slide is a summary of how damage and loss models at the component level can be used to find cumulative damage for each wind demand, which involves an iterative analysis where demand and damage are coupled. And then if the building envelope is breached, then internal pressurization will occur and pressure will be recalculated and the asset needs to be rechecked for damage. And this continues until a steady state damage condition is met. And then, of course, the final state of the building envelope will affect the amount of rain that enters the building. And so just to be explicitly clear, this whole workflow is not currently implemented into PELICUN and PBE. Currently, the PELICUN and PBE tools only support the probabilistic simulation of wind pressure damages on components, meaning that debris and and rain losses are not considered at the moment. And also the iterative analysis of damage has to be done in a post-processing script. If you're interested in testing out these new tools, we're currently working on compiling some resources for an illustrative example of component level damage and loss assessments from hurricane wind. And this illustrative example will include all of the resources to recreate the simulation, which are the WEUQ inputs, the WEUQ outputs in the form of pressure, asset descriptions for a case study building, outputs from an analysis using that PBE application, or alternatively, a script to perform these analyses in a Python environment using PELICUN. And then finally, that post-processing script to assess damage to the building. So even though, as I mentioned, these resources are not quite ready yet, they will be coming in the next few weeks. And I just want to plug that I think after the roundtable, we'll be sending out a sign-up form where you can indicate if you're interested in getting your hands on some of these resources. And yeah, so if you're interested in reading more about this work, we currently have a paper that is in production, and the name of the paper is on the screen if you want to keep an eye out, or alternatively, feel free to message me at any time, and I can make sure to keep you in the loop on when that becomes available and published. And then that QR code all the way on the left is going to take you to a Google Drive for our supplementary resources, including that database of all of the papers that we reviewed, as well as that calculation set and our tables of model parameters. And so with that, I would like to say thank you for this opportunity, and I will close with my 3 questions that hopefully spark some community discussion.
Perfect. Thank you, Rachel. So just to kind of recap for folks that are on this roundtable and starting to see some of this, we are trying to also triage questions that are coming in through the chat. But again, I remind you, you are welcome to use the Q&A function or the chat to direct those questions. But to recap, Rachel, if you could drop the links in for the QR codes that were provided, that would be immensely helpful. I want to help the attendees understand and appreciate what you're seeing here. First, the systematic organization of a tremendous amount of fragility information that currently was fragmented across the literature has now been compiled and organized in this kind of systematic framework in accordance with the performance-based engineering approach that you would see, and have seen in the earthquake engineering community, using that as a framework now for some of the different hazards in the wind community specific to hurricanes. So while this paper is in production, we expect and hopefully we'll see the proofs in DOI minting soon. Rachel is able to provide you with 2 resources that you can engage today. The first is the literature database. It's the second link that you see in the chat there. But Rachel essentially is providing you with an inventory of all the literature that we canvassed and organized into this framework and are now bringing into our workflow for your use. So think about all those fragilities you might have seen in the literature and that are in this database now being at your disposal to do and use in your work through the SimCenter. That's pretty exciting in itself, not just for regional simulation, but even in looking at the performance of, let's say, an individual building. Secondly, the link right above that is the GitHub repository, showing you how we're bringing those assets not only through a state-of-the-art paper and a database of the literature, but actually bringing them to life so that you have access and can use them, and you can take a look at some of what we've done in our GitHub repository. So Rachel, thank you. I want to make sure people appreciate the 2 links that you're dropping in there. And I think that one of the questions you have here is an interesting yet tricky one. As the community gets to dig in for the first time ever, and this paper is just about to hit, so everyone may not even realize I guess it was, 70 different studies that were canvassed and systematically organized to be able to look at pressure, debris, wind-driven rain, these important hazards for the wind dimension of a hurricane. As people dig into your Google Drive database to see all that literature and those models that we ultimately found through your work, I think they might be able to come up with other things that either they would like to see, could contribute, or literature we might have missed. So I believe our second step here to help generate more engagement with this resource is we will be circulating a Google Sheet or form where you can add to this database. You can direct us to resources and other models that are out there in the literature, perhaps in your own research group, that could be incorporated into this over time. Because your effort, as you indicated, was canvassing this literature, but we may not have captured it all. So anything you would really like to highlight, Rachel, that you'd love to see community members possibly elevate to our attention and bring into this first ever attempt to organize the WIN literature this way?
Sure, yeah. So I think in our canvassing of the literature, I came across a lot of single family residential archetype, either experimental lab studies or integration into community scale risk assessments. And I think there is a lag in either the commercial building or high-rise building risk assessments with the component level. So even though there are some examples in the literature, I mean, I think we found some fragilities or some papers that use component level window fragilities to do facade assessments on high-rise buildings during a hurricane. But I would love to see the just more of that content being added to the amount of residential homes that we've been seeing. And on that note, on the opposite end of the spectrum as well, perhaps even, I don't think I came across one with mobile homes as
Manufactured housing.
yeah, or manufactured homes. So I think that would be a really interesting contribution as well.
Yeah, I think, we were sort of at the mercy of where the literature sits today. And one of the important parts of this state-of-the-art document, this paper that's going to appear in the Journal of Structural Engineering, is even highlighting the gaps we saw. As we mapped where the community has done its work so far in the academic literature, there are clear gaps, both in the archetypes and types of structures represented, but also in the parts of that kind of chain, if you will, that are underrepresented in the descriptions that we have available today in the literature. So I think I would encourage community members to look at those gaps. We had two questions that trickled in other ways. So I want to first come over to Jordan's, which is visible in the Q&A, but we have another from a colleague who could not use the Q&A, Mohammed, and we'll get to both of those. But to Jordan's first, the database is uniquely creating fragility functions for a given set of attributes based on a combination of component fragilities to assess overall building performance. Have you compared these to what's being used in HAZUS? It's not necessarily that you're uniquely creating fragility functions, you're organizing these component or subassembly level fragilities that are out there and putting them together in a framework so we can see where they map in this overall PBE kind of, thinking, right? So it's at different resolutions and different hazards, and you're mapping what's out there right now, correct?
Right. And I will add to that. So the HAZUS fragility functions fit, as Tracy mentioned, into the framework at the building level. And
Rachel, do you want to go back a few slides to show them that the way we organize the literature has these multiple scales, if you will, from building level? If you go back a few, it could help clarify that. Let's see if we can get it. There we go. There we go.
So where the HAZUS functions would fit in are probably somewhere around this definitely somewhere around this 3.3 building damage model. And then we have the component unit fragilities, which is most of what I presented on today, sitting at this 3.1 space in our framework. But that being said, I think that one of the potentials for this work to go and be reused, potentially the new component fragilities, is that you can kind of build your own building archetypes from the components. And if you're interested in the HAZUS building archetypes, you can use our component level or high resolution fragility parameters to perhaps calibrate any building level damage functions that you are interested in using to compare against HAZUS, or just do an alternative validation study as well. So I think the opportunities are really there to compare against existing building level fragilities with these new component level fragility functions.
Yeah, so Adam, did you want to jump in on that?
Yeah, if I may, just really briefly, because I know that Jordan is working on some new and enhanced building level fragilities. I just want to indicate, not only to Jordan, but everyone, that we are not only focused on component level. So if someone is working on improving the building level fragilities and loss functions, those have a place in our damage and loss library as well. And we can include them, and we can reference your work and help others use the results of your studies. So please don't hesitate to reach out if that's what you are interested in.
And I want to shout that part out in particular. We recognize that we're organizing, compiling systematically the existing literature, but with important metadata capturing the origin of that, right? So we're capturing that so that you get that proper credit. And I think that was an important commitment that we made in bringing this all together in a systematic way for the community. Adam, I know that we were thinking about trying to get this question in. I pasted it in the chat if you're able to see it. A colleague sent it by a direct message to me during this conversation, was wondering about correlation between the fragility parameters. How have we thought through that? Because that's, of course, a tricky thing when we start talking about what's happening in something as complex as a hurricane.
Yeah, so the question asks if we have considered correlation between these fragility parameters. What I can tell you is that we are aware of this as a need, and there's a particular model that we will build into PELICUN that will be able to consider correlated fragilities within a system. That system could be a building with different components. This is something that was developed as part of the update to FEMA P58. So this is on the seismic side, but it's agnostic to the hazard. There's a paper by Jack Baker from last year. I can copy the DOI here in the chat in a minute. And it allows us to efficiently include this type of correlation structure and make it easy for users to parameterize those dependencies, because that's also pretty challenging. And we will build that in and make it available not only for seismic applications, but also for wind and also for infrastructure. Another area where this could come in is bridges in a network that could have correlated fragilities. So all of those are going to be enabled in the near future by this update that we are working on.
And I think that's one of the beautiful highlights of the SimCenter is the fact that what we're learning from different hazard groups within our community actually can feed into and elevate the capabilities across other hazard groupings and communities by building them into these workflows that then serve multiple hazards. So I think that's kind of exciting. And just quickly, as Greg had chimed in the Q&A as well, he was asking about how much data have you found to characterize component damage as a function of wind pressure that could be used in component-based assessment. And we do see some spottiness in what's out there in the literature, right? Can you recap for Greg how much data you've actually found?
Yeah, absolutely. I think that let me just go here. In the library itself, we have over 100 fragility parameters, but with the diversity of components, that's all summarized in this table here. And so the typical roof-to-wall connection, windows, doors, openings, other openings, and then our sheathing and roof and wall cover are the common components that are seen in those single-family residential analyses. And then we have some more rare but other components that also have been found we've also found fragilities for in the literature.
And just to Rachel's point, though, the richness of these parameterizations or what will be required will change with different archetypes. And certainly as we get to different classes, commercial buildings, others, we're going to need to deepen that as well. Adam helpfully dropped in that paper by Jack for reference on what we're trying to kind of cross-train across the hazards, if you will. And just reminding you again, that Google form that you'll see earlier up posted by me is a great place to help highlight to us what fragilities we might be missing. Now that you can see Rachel's initial database, and when that paper comes out, I believe a lot more to come. So thank you, Rachel, for that and that conversation. And with that, we're going to ask you to stop share and bring Barbaros up, who's going to bring up the last part. And that is, we can't talk about describing damage and loss until we know how to characterize the structures themselves. So let's take a look at how we get those inventories. Barbaros?
Thank you, Tracy. So for my presentation, I'm going to be mainly talking about, if you haven't heard of the tool yet, Braille's++. and how Braille++ can be integrated or interfaced with another SimCenter tool, R2D. So I'll get straight into it. What you're seeing right now is a screen capture of an inventory created for one of our test beds, Lake Charles area. And what you're seeing in red is basically the building inventory for the region. You're seeing in green is the transportation, and in yellow you're seeing the power infrastructure. Inventories completely through Braille's using Braille's++. What I want to do, just so that you understand the approach Braille's++ follows, is break the approach into its individual components and talk about each piece a little bit, just so that you have a good understanding of the approach. Braille's uses 4 principal approaches to characterize attributes of the build environment. It initially started with the image recognition approach. As you know, there's an abundance of street level and aerial imagery available, publicly available, and easily accessible. Braille's basically has methods to automate, harvesting that data and recognizing the attributes that might be relevant for natural hazard studies. In addition to that, Braille's is also able to pull data from a vast amount of data sets that are now available for buildings, power and transportation infrastructure. And wherever data cannot be obtained, Braille's also has methods to do what's called statistical imputation, which is basically figuring out missing data based on what's available. And last but not least, Braille's also has methods built into it to use rule sets to infer attributes that will be otherwise difficult to obtain from images or other databases, or perform inference for, again, data attributes that are not otherwise available. So I'll talk about each of these components a little bit, and basically give you an overview of the kinds of attributes you'll be able to obtain with Braille's++. And last but not least, one of the new updates to Braille's also allows for it has a very open and flexible architecture that allows for easy integration of new modules into it. So up until now, mostly Braille's++ has been a product of the models and approaches that we've created, or created by some of the senior staff that is involved with SimCenter. But we're at a point now where if you have a model that you think would be good for inventory creation, Braille's++ allows for easy integration of that model, and easy dissemination of your work for other people to use. So I'll speak on a little bit on the image processors, the image recognition approaches. Braille's uses very simple input from users to create these inventories. Right now, I'm basically highlighting the image recognition, but this applies to basically all 4 components of Braille's++. You can enter a location name, such as if you're interested in getting the building inventory for Berkeley, California, you can just enter that name. Or you can define a bounding box, or you can provide your own imagery, which could be near rapid imagery. What Braille's does is it basically automatically extracts the geometric features of the built environment within that defined region, and automatically gets the imagery for that region and runs them through a number of computer vision models that can be fine-tuned if necessary, but a lot of these models are now at a point where we've actually trained them on a vast majority of the United States, and what will come out of this kind of a pipeline that you can run in Braille's++ is that is a high-fidelity inventory that contains attributes that you might otherwise not be able to extract from public data sets or elsewhere. Just to give you a gist of the kind of attributes we're talking about, Braille's++ covers right now buildings, transportation assets, and power networks. For buildings, here's a list of the attributes you can get. You can get things ranging from the type of roof on a building, the number of floors. You can get attributes that are a little bit more complicated, such as the roof slope, the pitch, first floor height or elevation, or window density, the ratio of the windows to the rest of the facade area. So there are plenty of attributes you can obtain through imagery, and Braille's provides capabilities to do this in an automated manner. Just to give you a sense of some of these approaches we're using, so it could be as simple as classifying an image as a whole. This will be a good example of a roof classification type of approach, where we have a multi-class transformer architecture that is able to read data from Google aerial imagery, which was trained on 100,000 images, and can predict roof types with a fairly good accuracy, as you can see in the confusion matrix. Something similar that is done on basically sub-objects in an image is object detection. In the example of number of floor detection, we're looking at basically rows of windows that are detected automatically by a model. This model was trained on 60,000 images, puts bounding boxes around rows of windows, and gives you the number of floor predictions with around 86% accuracy in the wild, being for the kinds of setups that we will be dealing with. We also can automate Braille's can automate the obtaining metric measurements of a building by running a segmentation model that is custom trained for Braille's, and rectify basically undistort an image to obtain the characteristics that are needed, and basically do post-processing on them to get a wide range of features, some of them that I listed earlier in the table. And we've sort of mostly talked about training models, but Braille's also provides methods to sort of automate the pipeline of developing these models, and for that uses some of the latest vision language models, and it basically as a new sort of dependable vision language model comes out, Braille's is able to pull that in and use it for some of the applications that I mentioned for extracting building attributes. And that's just one piece, right? So we're able to pull data from images, data that's typically not available. But Braille's also automates the process of getting data from available resources, as in the sense of data scrapers. You're seeing a bunch of icons of a number of the data sets that we're able to pull data from. I'll give you some sort of samples of the data sets that we're able to get data. We're able to capture building geometry from OpenStreetMap, Overture Maps, Microsoft Global Footprints, FEMA USA structures, and not just the geometry. If they have an attribute that will be relevant to natural hazard studies, Braille is able to pull that in automatically, and process it in a way that will be meaningful for natural hazard studies as well. We're able to get other building features. For instance, national structures inventory. We're able to pull that in and merge it with some of the other data sources. For instance, if you're familiar with national structures inventory, it would consist of point data. We have automated methods in Braille's that would merge that data into footprints, for instance. We're able to get flood information for buildings. We're able to get wind zones, expected wind speeds, design wind speeds from ASC APIs. We're able to get land cover data as well for buildings. In addition to that, for transportation systems, we're able to pull data from basically all sort of well-acknowledged data sets in the US, as well as OpenStreetMaps for added flexibility or added coverage for other parts of the world. And last but not least, we're able to pull right now power infrastructure data from Highfield and OpenStreetMap. And you know, again, that process is completely automated. So all you need to do is basically just enter the name of the region that you're interested in creating these inventories for, and Brails will do that automatically for you. And say you found, I think in the particular case of Florida, for instance, that many areas will have, you know, tax assessors data readily available, and you have that data set and you want to enhance it. Brails also allows that. You can sort of start your Brails inventory creation with that data set and add the columns that will be necessary for you. I know, for instance, one example, it's hard to find roof shapes for buildings. There's no data exists. So you can add that column fairly easily with Brails. You would enhance your tax assessors data set with that. As I mentioned, we also have you know, methods to sort of address the challenges associated with missing data. You know, some particular cases of this would be, say, we can't get the street level imagery for a building. We cannot, you know, extract certain attributes for that building. But say we've extracted you know, those attributes of interest for neighboring buildings. So we have statistical imputation methods to address a situation like that. Right now, Brails includes the KNN method, and soon coming up is the Gaussian process and random forest. You can think of this in the very simple sort of sense, even though these algorithms are actually a lot more complicated and sophisticated than that, is a spatial interpolation type of method. But I guess the upside of it is it gives you not sort of the predicted values only, but it can also give you the uncertainty associated with that prediction, which you can sort of trickle down in your analyses. And we're able to, you know, right now in Brails++, there are a number of rule sets that we call inference engines built in that will also give you the opportunity to, you know, take some attributes that are already available or were already predicted by Brails, and then based on those predict some of the attributes that are otherwise difficult to get. So this could be just a missing attribute, or it could be something a little bit more sophisticated. Say you're doing hurricane analyses and you want to figure out what kind of connections you can expect for the roof connections. Brails has a module that pulls basically rule sets from HASIS and will basically give you that information. The whole development process basically revolves around what is needed, what does the natural hazards community need, and you know, using that as a roadmap, we basically developed these tools to close all those gaps, the needed attributes that are otherwise really difficult to obtain. And I'll touch on some of the upcoming features of Brails. And we'd like to hear more from you. You know, what will be of interest, you know, at the end of this presentation. But I'll sort of briefly touch on these. We're in the process of sort of developing the capability to identify you know, separation between individual buildings or vegetation. So this will be relevant to the hurricane type of studies, and you know, those of you may be interested in wildfire kind of studies, that might be something interesting too. What you're seeing here is basically a model that automatically extracted the mass for, you know, elements of interest, in this case buildings and trees, and you know, sort of automates the process of extracting you know, these distances. This is an upcoming feature that is not available that we're hoping to release in the future. Another one that was actually primarily my my work for my PhD studies was sort of automating the inventory generation for transportation systems, particularly buildings and tunnels. You know, just purely from imagery, you know, extracting detailed dimensions as opposed to just sort of like the span length and other things that you will be able to find in National Bridge inventory, for instance. Last but not least, we're working on ways to enhance the data that's already available in public data sets for power systems. As you can see, I have a random image sort of thrown into a segmentation model. This is actually a vision language model that I haven't even trained. This is just readily available. That can basically segment out parts of the power network, and hopefully, give us some of the attributes that will be of interest, such as maybe like the pole heights and types and so forth. Again, this is an upcoming feature that is not available on Braille's, but we're hoping to get at least portions of this methodology in soon. In terms of accessing, these tools that I mentioned, I've really focused on Braille's plus, but it's most meaningful when you can couple Braille's plus with R2D, and we basically done. We follow basically two sort of principal approaches here. Braille's is available to you as a standalone product. If you're willing to use Python command line interface, it's available in the GitHub repo. I don't have the link down here because you can easily just look it up. You can just go Braille's plus GitHub, and you will see that repo with all the code available for you to sort of see and digest. The documentation also available, sort of going over all the capabilities with examples. We also have a graphical interface to Braille's in R2D that's able to pull inventories. It's I have to note here, it's in the process of being upgraded. So some of the capabilities that I demonstrated in this presentation will not be there yet, but will be soon in there. So there's two options you can use to interact with Braille's. I'll just give you for the next maybe 30 seconds a gist of what that graphical interface looks like, just to show how you can. It gives you a good overview of Braille's capabilities for buildings, and it sort of shows you, some of the things you can do with Braille's. So we'll go ahead and do that. And we have a widget for buildings and transportation. For power, we don't have something yet, but I'm expecting that to be out fairly soon as well. So this is just creating building inventories for the Berkeley region. As I mentioned, you can just enter the name of the region that you're interested in, and it will just get the data needed for it. What you're seeing now is it's pulling the NSI data for that region automatically by pressing a few buttons. This button right here basically merges that data, so that the point data that you see from NSI is now merged into the footprint that we were able to pull using Braille's. And then next, what you're going to see is basically these are the vision-based approach attributes you can get, using Braille's. Just with the hit of a button, you can basically enhance your inventory, starting with maybe NSI data. So that just about wraps up my presentation, and I want to leave everyone with these three questions. And maybe I'll hand it over to Tracy at this point.
All right, thanks, Barbara. So I hope in this little quick presentation, people can get a sense of the versatility we're bringing in through Braille's plus. Essentially solving these difficult problems of how you digitize effectively these environments that we're working on in the application to hurricane and other hazards as well, right? It's not just for hurricane simulation. And your first question, Barbaros, is like, what features or functionalities would the community like to see for inventory generation, right? Braille's plus has its capabilities. We're improving that GUI interface using R2D, but Braille's plus, the repo there at GitHub is in the chat. I put it there for folks to see. And I think Francis has a question in the Q&A that might tie perfectly to your question one. Transportation networks, it's one you showed. It's one of these lifelines that we know is critical in a hurricane scenario. And the question is, can things like speed limits, number of lanes, even evacuation signs, seeing what are the evacuation routes, how can we get that? And I know you've been thinking of many rich data sources that answer a lot of those cool questions. So do you want to play around with that a bit?
Yeah, speed limits, I believe there's data sets that are already available that are not free. So that's something that could be pulled into Braille's if that's of interest to community. But in the sense of, I think, evacuation, things just get a little bit complicated, right? So those speed limits, I don't know if there's changes to them in an evacuation scenario like that. So that would be something interesting to hear from the community, how we should bring that data in. But speed limit data, as far as I know, is available. relatively, easily accessible. In terms of number of lanes, I think so. I think maybe the short answer is almost all of these attributes can be obtained through vision-based approaches, in my opinion, relatively easily too. We haven't really put the sort of like the effort to bring that in just yet. So if the community thinks this is needed, and if we have the bandwidth, this would be very interesting to sort of look into. Yeah, I mean, I think these are all sort of difficult to get attributes, except for maybe speed limits.
And I was curious also, Rachel, when we were playing with optimization of route selection for sampling data in hurricane events, one of the things was thinking about using the Google Map API as a way to pull real-time kind of traffic simulation. And so I'm wondering if that becomes another, because the goal here is that we don't just lean on vision-based techniques for everything. We use the capabilities that we find in this more robust version of Braille's to let us federate and stitch together data sources that are the best fit for the questions we have. Rachel, did you have any thoughts, like as we played with that, of maybe for our colleague who's answering the question about evacuation, to Barbaros's point, speeds and congestion change that? Is that something we could play with and pull, out of that API and then start capturing during real-time evacuations in future hurricanes?
Yeah, absolutely. I actually, if I remember correctly, do have scripts that pulled graph networks for roads, and they had corresponding speed limits for all of the roads, as well as they labeled what type of road it was, so like residential, primary, tertiary, and it was all free. This was not through Google. I think it might have been through OpenStreetMap, but I'd be definitely more than happy to take a deep dive on my
but like the route API that we were using to actually calculate drive times.
Oh,
to Francis's question, I was thinking Barbaros is correct. When things get congested, no matter what the road condition was in its daily servicing, it's a very different scenario when we're in evacuation with maybe cars backing up because it's a rapid landfalling hurricane. Everyone's rushing out at the same time rather than phased. I'm wondering if we could capture that in the same way you would be looking at route congestion in any other driving scenario using Google.
Right. I think it was relatively straightforward with the route API and like pretty robust to get a route matrix if you give it a list of origins and destinations. So I think theoretically it would be possible. And with it mostly depends, I think, on how rapidly Google updates their traffic settings
for that
during an evacuation event.
It would be interesting to capture that and try to see as a living laboratory almost if this is actually able to be done in this way, because I think Francis raises an important question for evacuation simulation. I would also add that many states have an open layer available in their open, GIS that shows evacuation routes with additional metadata on those evacuation routes. So at a unit level, those can be brought in to give the baseline grid that the traffic patterns will follow, but you still might need real-time analytics. Another tool that I use for this is something called Junction Analytics. It's a product that's sold. It's got a service structure, so you have to pay for access, but it gives real-time traffic flow monitoring. And I can drop a link to that tool. I've used that one as well, because that's really the most precious data, is that real-time traffic data when you're under a stressful condition. Barbaros, as I dig a little bit, the other point of reference is where the evacuees go. Indeed, I'm wondering if real-time monitoring those traffic flows by capturing things out of that route API, for example, or from these analytics through TomTom, and I'll drop a link to that, could actually capture that. And again, knowing which routes are allowed to be open during the evacuation, which the states do publish in advance, you would then know which routes to monitor and create destination points on to monitor. I'll drop a link for that to Francis's point. But Barbaros, as you answer that, also take a look at Saeed's question about occupancy and wall type. But if you want to elaborate more on the routes, feel free.
Yeah, so something I wanted to also highlight is even though we don't really capture that data, number of lanes, speed limit, etc., we do have some post-processors that are able to make assumptions on those. So even though this is not ground truth, You can, through Braille's, get that data based on the assumptions that are made. So that's something I wanted to highlight. Basically, also stating that these are sort of, approximate approaches as opposed to grounded in real data. In terms of the graph network that Rachel mentioned, so we're able to get that data from US Census Tiger polygons and OpenStreetMaps. And if OpenStreetMaps actually, whenever it has that data, it will be also on Braille's too. So if OpenStreetMaps states the speed limits, that will be in Braille's. But one of the pitfalls of OpenStreetMaps, unfortunately, is data consistency. So you can have that for certain segments, but not the others. So that's some of the sort of capabilities to touch on. And I guess one last thing to highlight here is what you can generate in Braille's ++ is actually a graph network, meaning you can actually take that and plug it into our traffic simulation models in R2D, and you can run traffic simulation. So if you have a sense of where your evacuation points are, basically with minimal work, you're able to create your origins as well. You can run those simulations fairly easily as well. In terms of the other question, I think the question goes, does Braille's ++ detect the occupancy type and structural types of buildings as well? In terms of occupancy type, Braille's ++ has a simple vision model that can distinguish between residential and non-residential buildings. And it also has a module that could parse the data in National Structures Inventory in a way that will basically parse the data into hazards classes. So far, that's what we have in Braille's ++. In terms of structural types, I think maybe in the sense of if the structure is wood, concrete, steel, etc., we have a vision-based model that's able to make this prediction. We also can perform that same prediction from National Structures Inventory in Braille's ++, with the latter being, I think, a little bit less dependable, at least based on our observations. The structure type predictions of Braille's ++, I think, are right now around 70% accuracy from images.
Yeah, definitely difficult to see what's behind the skin and get that
Absolutely.
accurate.
Absolutely.
Jordan has a question in the Q&A, and I'll parse it in two parts to help direct you to it. It's got a lot of detail. The first is, can we do historical data? Because one of the challenges are we serving up only the latest version, which may not be helpful in a hurricane when you want to see pre-post, for example.
So this is interesting because this is something that I was just very recently involved in for Fort Myers that Adam mentioned briefly. So we just recently enabled the capability to pull historical images of buildings on Google Street View. When you go to Google Street View, there's like an icon where you can click and you can see earlier versions of a photo. Now you're able to pull that data using Braille's ++, free of charge, by the way.
Good plug.
Aerial imagery is a little bit more complicated. This is how I sort of hacked it. What I noticed is Bing Maps aerial imagery is not updated as frequently as Google Maps imagery. So for Fort Myers, I was actually able to get pre-Hurricane Ian images using the Bing Maps base map layer, and was able to do that. So I think maybe this won't be consistently always the case for every region. And I think as the time goes by, I think both sources will be updated to a post-event, sort of state.
Yeah,
but I was able to sort of do a hack like that, at least for Fort Myers.
And did you see variation in performance with older imagery data? Because often, it doesn't have the best resolution. And I think Jordan was noting, like, if you looked at 2017 Harvey data, do we expect to see a change in performance as we try to go back and get those features?
And that will be another, I think, pitfall of this sort of approach. Yes, 2017, I think at that point, we weren't really capturing the aerial imagery at the resolution we're capturing them now. And something I also noticed is that there's an inconsistency between the Bing aerial imagery versus, Bing Maps aerial imagery versus Google Maps aerial imagery. So those are all, I think, likely pitfalls. But I think with some hacking, at least. It's possible.
And the other question, just to get it there from Jordan, a lot of the features we're starting to bring into Braille's Plus are helpful for resolving features of the envelope relevant to wind performance. She was curious about mean roof height. It's one of the parameters that we were deriving out, at least as a secondary variable for buildings. But any thoughts on how efficiently that's now getting extracted out of Braille's Plus?
We're able to extract it. We validated the building heights. So, I mean, our validation shows we're capturing it fairly well, but I don't have a specific validation for mean roof height just because it's hard to get that ground truth data. But we're able to capture that information in Braille's Plus at the moment.
Adam, did you want to add something? Sorry, I saw your hand up.
Oh, maybe just really briefly, I wanted to mention when Barbaros was talking about the historical images that I think we should consider those perishable data, just like we consider many other data sources like that, and collect it as soon as possible if there's an event. Because yes, there are these shortcuts for some time, but they won't be available 10 years after the event. So I think this is one more reason to have that kind of data repository for specific events and try to collect as much of the valuable data as possible, including images, or if images are not possible because of licensing issues, then try to extract as much as possible from the images and collect that data. That's all.
Yeah, thank you, Adam. And I think especially we have so many opportunities to learn from hurricanes because they recur sadly so frequently, that actually stamping these and benchmarking them as regions are hit repeatedly is also critical, so we can look at the collective and cumulative effects of these disasters over time. We certainly saw that in Florida with the most recent seasons, in the Fort Myers area in particular. So with that, I just wanted to thank all the attendees for coming to the roundtable. We're taking this insight and conversation into our continued development efforts. And as Adam suggested, we are so eager to continue to hear more from you about what you'd like to see in these capabilities. You can always come into the SimCenter's website, go to the Collaborate and Join Community subpage to find out how to get engaged with our community roundtables, or to subscribe to our newsletters, or just send an email if you have more questions or a desire to get involved, either to contribute or become a more active user of these tools. I'll also plug that we have more roundtables coming up. If you're curious about surrogate modeling, there's a roundtable next week on that. And we're continuing our conversations around wind, regional simulation for earthquake, and power infrastructure, which is one that came up a little bit today and is certainly one that's critical for us to continue conversation around. Even if you can't make this testbed, these roundtables in real time, we always have the recordings on our website so you can take advantage of learning later. And we hope at minimum we'll see some of you perhaps at the Americas Conference on Wind Engineering, where the SimCenter will have great representation and a workshop to help you learn more about how to apply these tools in the context of wind and specifically hurricane regional simulation. So with that, I thank everyone for their time with us this evening or late afternoon, depending where you are. And we look forward to seeing you again at a future SimCenter event. Goodbye, everyone.